Good evening, everyone. Today we are going to see progressions. Progressions in the sense like there are two types of progressions that we are going to see today. Generally, we have arithmetic progression, then we have geometric progression, and then we have harmonic progressions. So most of the questions will be asked in arithmetic and geometric progression. Okay, so we will be discussing these two concepts in today's video, and harmonic progression we will discuss in our intense placement training. All right, and mostly the questions asked in progressions depend on formula. Okay, so in this session what I'm going to do is I'm going to give you the formulas, and also I'm going to explain how those formulas are derived. Okay, so that even without knowing the formula, using the logic, you can solve the questions. All right, quick announcement about our live coaching. So from January 2nd we are starting our training. Every Saturday evening and Sunday morning we'll have weekly test. So whatever is handled on Saturday and Sunday, so Sunday evening we'll have a test. That is also included in this. So visit this website. The website link is given in the description box and also in the chat section. So if you want to enroll, please visit this and enroll as soon as possible. All right. Now, first let us see what is arithmetic progression. Okay. We need to understand what is arithmetic progression. Okay. Surabhi, is my voice okay now? Please let me know if you still face that issue. Please let me know. Okay. Okay, great. Fine. Now, see here, arithmetic progression is something where a series of numbers. If first term is x, next term will be x plus d, where d is the difference. The third term will be x plus 2d, x plus 3d will be the next term. Like this, every time, if the first term is x, next term will be x plus d. Third term will be x plus d plus d. So whatever is there in the previous term, to that we will add that difference to get the next term. Like that, it will go on. For example, let us say 5, 8, 11, 14, 17, and so on. If you see, the difference between 5 and 8 is 3. Difference between 8 and 11 is 3. Difference between 11 and 14 is 3. Difference between 14 and 17 is 3. Like this, the successive terms or the closest terms will have difference which is common throughout the series. These kind of series are called as arithmetic series or arithmetic progression. All right. Now we have three different parameters. One is A, the next one is L, and the next one is D, where A is first term. We represent the first term of the series using the term A. L is last term. L is last term. D is common difference. Okay, D is common difference. Now, using these parameters, we will try to express formulas for different, requirements. A, L, D. Nth term of a series. Nth term of a series. I have to find out nth term. Now, let us take this series for example. 6, 10, 14, 18, 22, and so on. If I need second term, what will I do? From the first term, I will add 4 to get second term. Or I can say to the first term, I am adding 1 times 4, right? If I should get 14, what will I do? To the first term, I will add 2 times 4, right? I will add 2 times 4. All right. Now, I will get 14. If I need third term, what will I do? To the first term, I will add 3 times 4, right? I will get 18. If I need, see, for second term, I am multiplying with 1. For third term, I am multiplying with 2. For fourth term, I am multiplying with 3, right? If I need nth term, what will I do? To the first term, okay, I will add 4 multiplied with n minus 1, right? If I need nth term, to the first term, I will add 4 multiplied with n minus 1. So, nth term can be formed using the, found using the formula a plus n minus 1 into common difference. A plus n minus 1 into common difference. This formula can be used to find out nth term. For example, in this series, 6, 10, 14, and so on. If I need 20th term, what will I do? 6 plus 20 minus 1 into common difference is 4, right? So 6 plus 19 into 4, that is 6 plus 76, I will get 82. That will be my 20th term of this series, right? So nth term is a plus n minus 1 into d. Now, if I need number of terms in a series, see here, number of terms in a series, what I can do? Do we know that average into number of terms gives sum? Average into number of terms will give sum, right? Now, if you see 2, 4, 6, 8, 10, these numbers are in arithmetic progression, right? Now, whenever you have like this, the middle term is the average. When the number of terms is odd, okay, number of terms is odd, middle term is the average. If you take 2, 4, 6, 8, 10, and 12, in this case, average of middle two terms will be the average of the complete series. Okay, average of the middle two terms will be the average of complete series. So 7 will be the average here. Okay, now this average here, average is 6. 6 into number of terms is 5, that will give you 30, right? That is sum of the terms. We can also say number of terms is equal to sum of the terms divided by average, right? We can also say number of terms is sum of the terms divided by average. Like this also we can find out. Okay, so when average is known and sum of the terms is also known, you can find out number of terms. Now, how do we find out average? See guys, so nth term formula, I'll write it one more time. Tn is equal to a plus n minus 1 into d. See, when a set of numbers is in arithmetic progression, 1, 2, 3, 4, 5, 6, 7. As I told, the middle term will be the average, right? Number of terms is odd, so the middle term will be the average. We can also find out average in a different way. When the terms are in arithmetic progression, you can add first term and last term and then divide it by 2. 1 plus 7 by 2 is what? 4. Or second term plus second last term, 2 plus 6 by 2, 4. Or third term and third last term, you can add them and divide it by 2. In this case also, you'll get the same average. This is possible only when the number of or the terms in the series, they are in arithmetic progression. Okay. Now, number of terms, sum of the terms, sum of n number of terms, what we can do is a plus L, first term plus last term divided by 2. Okay, this will give you the average, right? First term plus last term divided by 2 will give you the average. When you multiply this with number of terms, what will happen? You will get the sum, right? This is sum of the terms of an arithmetic progression from first to last. Okay. Now, when first term is known and also last term is known, how do we find out number of terms in the series? Now, consider this equation itself. Instead of nth term, we will consider last term. Last term will be what? A plus n minus 1 into d, where there are n number of terms in the series. Okay. Now, when you simplify this, what will happen? Last term minus first term is equal to n minus 1 into d, right? Now, last term minus first term divided by common difference is equal to n minus 1, or number of terms is equal to last term minus first term divided by common difference plus 1, right? Last term minus first term divided by common difference plus 1. This will give you the number of terms in the series. Yeah. Okay. Yes. Adya, very good. N into A plus L by 2. That is the same thing. I have expressed it like, A plus L by 2 will give you average. Average into number of terms will give you sum of the terms. Right. So this is the logic behind it. But we can write it like this also. N into A plus L, or N by 2 into A plus L. Like this also. You can see it in some websites or books. Both are same. No difference here. Okay. So this is how we find out number of terms in an arithmetic progression. This is how we find out sum of n number of terms in an arithmetic progression. This is how we find out nth term of an arithmetic progression. Right? These three formulas are very important. Now, apart from this, in progressions, sequence and series, basically, you will also be asked with few other information like sum of n natural numbers. See, first n natural numbers. What is the set of natural numbers? 1, 2, 3. Starting from 1, it goes up to infinity, right? So this is natural. These are natural numbers. If they ask first n natural number, first term is what? 1, right? Last term will be n. So what is the formula to find out sum of n terms in a series? Natural numbers are in arithmetic progression with common difference 1, right? So sum value is A plus L by n. Sorry, A plus L by 2 into n. That is the formula to find out sum, right? So here A value is 1, last term is n, divided by 2 into n. This is how we got this formula n into n plus 1 by 2, which is for finding sum of n natural numbers. In many books, we will have this formula, right? N into n plus 1 by 2. How did we get this formula? Using this arithmetic progression logic. Average into number of terms. N plus 1 by 2 will give the average, into n will give you sum. Okay. Sum of first n even numbers. Sum of first n even numbers. How do we find out? For example, let us take first 5 even numbers. 2, 4, 6, 8, even natural numbers, okay? Because 0 is also an even number. I am talking about even natural numbers. 2, 4, 6, 8, 10. Can we consider this as 2 into 1, 2, 3, 4, 5? 2 is commonly taken outside, right? 2 into 1, 2, 3, 4, 5. Now, how do we find out sum for 1, 2, 3, 4, 5 or n natural numbers? N into n plus 1 by 2. And we have to again multiply with 2 so that, whatever sum is coming inside, that has to be multiplied with 2. So, sum of n even numbers, first n even numbers will be n into n plus 1. That's all, right? So 2 plus 4 is what? 6, right? So 2 into 2 plus 1 is 6. Two terms are there means it satisfies, right? N into n plus 1, that is enough to find out number of sum of first n natural even numbers. Okay, so for sum of first n natural even numbers. Okay, very good, Adya. Sum of first n odd numbers. Sum of first n odd numbers. So if I take a set 1, 3, 5, 7, and so on. What is 1 plus 3? 4. 1 plus 3 plus 5 is 9. 1 plus 3 plus 5 plus 7 is 16. Right? If you see the pattern, the sum is like this: 1, 4, 9, 16, and it will go on. Next will be 25, next will be 36. This is square series, right? If they ask for first 10, sum of first 10 odd numbers, your answer is 10 square. So sum of first n odd numbers is n square. That's all. Okay. Sum of first n odd numbers is n square. All right. See, sum of squares of first n natural numbers. Sum of squares of first n natural numbers. This will be n into n plus 1 into 2n plus 1 whole divided by 6. N into n plus 1 into 2n plus 1 whole divided by 6. Try to remember this. Okay. Sum of cubes of first n natural numbers. Sum of cubes of first n natural number. The formula is n into n plus 1 divided by 2, the whole square. To find the cube of first n natural numbers, you have to find the sum of n natural numbers and then take square. Okay. Sum of cubes of first n natural numbers. That means 1 cube plus 2 cube plus 3 cube and so on. All right. Okay. Here it is 1 square plus 2 square plus 3 square and so on. So these are the formula guys. N into n plus 1 by 2, n into n plus 1 for first even numbers, n natural even numbers, n square for first n odd numbers. For squares of first n natural numbers, n into n plus 1 into 2n plus 1 by 6. And for sum of cubes of first n natural numbers is sum of n natural numbers power 2. Okay. Great. Very good. Very good. Let us see the next question. Let us solve some questions now. What is the sum of first 12 multiples of 8? When they ask first 12 multiples of 8, what do you get? 12, 24, 36, and so on, right? What is, first 12 multiples of 8? It will be series of 8, right? 8, 16, 24, 32, and 12th multiple of 8 is 96, right? Okay. Now, you can do it in two ways. First term, we know it is 8. Last term is 96. Add these two and then divide it by 2, you will get the average, right? Because these terms are in arithmetic progression, you can add first term and last term and divide it by 2 to get the average. Into number of terms will give you the sum, right? Into number of terms will give you the sum. 104 into 6 is 624. That will be the sum of these values, right? What am I doing here? I'm using the average concept. First term plus last term divided by 2. 12 multiples of 8 means for 12th multiple will be 12 into 8, 96. That is how I got this 96. First multiple will be 8. So 8 is first term, 96 is last term. Since they are in arithmetic progression, I can just add first term and last term and divide it by 2 to get the average. Average is multiplied with number of terms to get the sum of the terms. This is one way of doing it, right? Or what I can do is, I can consider first 12 multiples of 8 like this also. 8 into 1 plus 2 plus 3 plus 4 plus up to 12, right? Now, what is the sum of first 12 natural numbers? 12 into 12 plus 1 divided by 2. N into n plus 1 divided by 2, right? That will be the sum of first n natural numbers. Now, 6 into 13 is 78. So 78 into 8 will give me 624. Like this also I can do. First 12 multiples of 8, I can take 8 commonly outside, and inside I will have 1 plus 2 plus 3 up to 12. So first 12 natural numbers, when I add, I get 12 into 12 plus 1 by 2, 78. That 78 into 8 will give me 624. Right? Any doubts, anyone? 12 by 2 into 2 into 8 plus 11 into 8. Yeah, that is also correct, Adya. You are just adding second and second last and dividing it by 2 and then multiplying with number of terms. Correct. 624. Sambhavi, very good. Dhanashri, very good. Dharani, Adya, very good. Monisha, very good. Right? Wonderful. Let us see the next question. What is the sum of the series 14, 20, 26 up to 104? Now, we know sum of the terms is equal to first term plus last term divided by 2 into number of terms. Right? Here, we do not know the number of terms. We have to find out the number of terms. How do we find out number of terms? Last term minus first term divided by common difference plus 1. Right? So 104 minus 14 divided by 4 divided by 6 actually plus 1 will give you how much? 90 by 6 is 15. 15 plus 1 is 16. Common difference is 6, right? Okay. So there are 16 terms. Now we can use this formula to find out the sum. Right? 14 plus 104 divided by 2 into 16. Right? 118 into 8, which will be 800 plus 80 plus 64, that is 944. Understood, guys? Very good. Adya, very good. Monisha, very good. Rupal, Kashish, Rohit, Tanuja, very good. Very good, guys. Very good. 944 will be the answer. Sambhavi, Saumya, Mangaldeep, very good, guys. Okay, let us see the next question. How many terms are there? Here you just have to find out number of terms. Number of terms equal to last term minus first term divided by common difference plus 1, right? So that is 141 minus 21 divided by 4 plus 1. So here you will get 120 divided by 4, that is 30, which is, so number of terms will be 31. Right? Very good, Mangaldeep. 31 will be the answer. Very good, Adya. Syed, very good. Very good. Sambhavi, Monisha, Rupal, Vinod, very good, please. Very good. So the answer will be 31. Kashish, Rohit, very good. Let us see the next question. How many 3-digit numbers are multiples of 5 and 7? Now, what is the smallest 3-digit number? 100. Largest 3-digit number? 999. Right? But we cannot consider all the 3-digit numbers. We have to consider numbers that are divisible by 5 and also 7. Can you tell me what are the numbers that are divisible by both 5 and 7? If a number is divisible by both 5 and 7, it will be divisible by what? This concept we saw in divisibility, right? A number is divisible by 5 and also 7, which means it will be divisible by 35. Very good, Rupal. Mangaldeep, very good. Kashish, very good. Adya, very good. It will be divisible by 35, which is just LCM of 5 and 7. Okay. Now, in this range, we have to find out what is the first number that is divisible by 35. 105, right? 105 divided by 35 is 3. So 3 times 35 is 105. So in our series, in actual series, 105 will be the first number, 140 will be the second number, 175, 210. It will go on like this. Now, what will be the last number, last 3-digit number that is divisible by 35? Now, all multiples of 70 are divisible by 35, right? 70 into 14, we know it is 980. When you add another 980 plus 35, it will go to 1015, which is actually a 4-digit number. So which means 980 is the last 3-digit number that is divisible by 35. You can find out like this, or you can divide 1000 by 35. What you will get? 8 times 35 is 280. Remainder 20 will be there. So from 1000, if you subtract this 20, you get 980, which is exactly divisible by 35. Okay. Now we have got our series. 105 is the first term, 980 is the second term. We just have to find out number of terms, right? 980 minus 105 divided by 35 plus 1. How much will this be? 980 minus 105 is 875. 875 by 35 plus 1. 25 plus 1, 26. Guys, this is one way of doing this. Okay, this is one way of doing this. Using arithmetic progression concept. There is also another way which is very simple for us to do this calculation. Okay, I'll explain that. See here, see this box. We know 980 is the largest 3-digit number that is divisible by 5. What is that? 28 into 35. 980 is the largest 3-digit number divisible by 35. Okay, 28 into 35 will give you 980. 28 into 3, okay, will give you 105. Now, just below this 105, the multiple of 35 is 70, right? So, 28 into 2 is what will give you this 70. From 35, sorry, wait 1 minute. (28) into 35 will give you 980, which is the largest 3-digit number divisible by 35. 2 into 35 will give you 70, which is the largest 2-digit number divisible by 35, right? To get answer for this question, 28 minus 2, right? 28 minus 2, 26. That is all you need to do. This can be achieved if you can find out the multiples easily like this, okay? 28 into 35 will give you 980. 2 into 35 will give you largest 2-digit number. 28 into 35 will give you largest 3-digit number divisible by 35. So from 28 subtract 2, you get 26. This will be your answer. All right. Very good, guys. Very good. Rohit, very good. Jyoti, very good. I'll explain this one more time. The second method. Largest 3-digit number divisible by 35 is 980. This 980 is 28 into 35. Okay. Next thing what you have to do is largest 2-digit number divisible by 35, which is 70. The 70 is 2 into 35. Take this value, 28 minus 2, 26, that is your answer. All right. If the same question, if they ask, okay, for how many 4-digit numbers are divisible? Okay, how many 4-digit numbers are divisible? 9,800 is divisible, we know that, plus 175, because 35 into 5 is 175. 9,800 is 280 into 35 plus 5 is 285. So 285 into 35 will give you 9975, which is divisible by 35. Okay. Largest 3-digit number is 980. That is 28 into 35. Now 285 minus 28 will give you 257. So there are 257 multiples of 35, which are 4-digit numbers. All right. So this is how we can do this. Okay. Now, next question. What is the 15th term? How do we find out the nth term? 15th term is first term plus 15 minus 1 into common difference. Right? So 45 plus 14 into 7, 98. So 45 plus 98 is 143. That will be the 15th term here. All right. Okay. Let us see the next question. Very good, Rupal. Kashish, very good. Let us see the next one. 10th term of an arithmetic progression is 65. 14th term is 97. Right? 10th term of an arithmetic progression is 65. 14th term is 97. So I will explain you the bookish way, and also I will give you the shortcut for this. 10th term is equal to a plus 10 minus 1 into common difference. Right? That means 65 is equal to a plus 9d. Similarly, 14th term is a plus 14 minus 1 into common difference. That means 97 is equal to a plus 13d. Now, when you subtract these two, what happens? 4d equal to 32. From this common difference, you will get it as 8. Now, you need a also. So 65 is equal to first term plus 9 into 8. Yeah. So a equal to 65 minus 72, which is minus 7. First term is minus 7. Okay. It can be negative value. Okay. Starting from negative value and getting into positive side. This is possible. Now we need to find out 20th term. Right? 20th term will be minus 7 plus 20 minus 1 into 8. That is minus 7 plus 19 into 8 is 152. So 145 will be the answer. All right, 145 will be the answer for this question. This is the method in which you can solve. One of the bookish methods. In books, they might have explained like this. Okay, very good. Adya, Bharati, Abhishek, Syed, Monisha, Rohit, Hema, very good guys, very good. So 145 is the answer. Now there is a different approach which can be used to solve this. From 65 to 97, from 65 to 97, how much is increased? 4 terms are increased, right? 4 terms are increased, 32 is increased. Number of terms is increased by 2 and number of the value is increased by 32. Okay. Now, from 10th term to 20th term, how many terms will increase? 10 terms, right? From 10th term to 20th term, 10 terms will increase. For 4 terms, increase is 32. For 10 terms, how much is the increase? Okay, for 4 terms, the increase is 32. For 10 terms, how much will be the increase? So when you simplify this, you will get 80 for this value. So to the first value, add this 80, you will get the answer. Right? When you increase 4 terms, the value increases by 32. So when you increase by 10 terms, by how much the value will increase? It will increase by 80. So 20th term will be 10th term plus 80, that is 145. Right? Understood the second method, everyone? Yeah? Okay. Now, let us see the next one. Geometric progression. All right. So let us see what is geometric progression first. I have 1, then I have 3, then I have 9, then I have 27, 81, 243. Like this, it will go on. So what is happening here? First term is multiplied with 3 to get the second term. Second term is multiplied with same 3 to get the third term. Right? Like this. Successive terms will be multiplied with same value, or we can say, see, in arithmetic progression, A3 minus A2 will be equal to A2 minus A1. This is arithmetic progression. Okay. In geometric progression, A3 by A2, that is third term divided by second term, will be equal to second term divided by first term. Okay. This is geometric progression. Here, first term is A. L is last term. Here, instead of D, we have R, which is common ratio. Okay, which is common ratio. Now, if A is the first term and R is the common ratio, second term will be A into R. Third term will be A into R, right? Or we can say AR square. Fourth term will be AR power 3. So nth term will be A into R power n minus 1. Second term is R power 1. Third term is R power 2. Fourth term is R power 3. That means nth term is R power n minus 1. A into R power n minus 1. This will give you the nth term of the series. Okay. A into R power n minus 1. All right. Okay. Now, how do we find out number of terms in the series? Now, let us say first term is A, last term is A into R power n minus 1, right? Okay. Or first term is A, fourth term is A into R power 3, right? Now, A into R power 3 divided by A will give you what? R power 3, right? One minute, guys. Yeah. You need to know the R value also. Okay. In this case, common ratio will be a known value. So for example, 81 divided by 3. Okay. First term is 3. Here second term will be, fourth term will be 81. So 81 by 3 is 27. Now 3 power what will give you 27. That will be your number of terms. Okay. 3 power whatever value will give you. Okay. 3 raised to the power 3 will give you 27. So this power value should be added with 1 to get the number of terms in a geometric progression. Okay. For example, first term is 2 and last term is 1024. 1024 and common ratio is 2. This is also given. Okay, common ratio is 2 is given. 1024 divided by 2 is what? 512. 512 is nothing but 2 raised to the power 9. So number of terms will be 9 plus 1, that is 10. Right? Number of terms will be 10 in this case. All right. So like this we can find out number of terms. Okay, Uday Kiran, whatever you have mentioned here, that is sum of the terms, right? That is for sum of the terms. There are multiple cases in that also. Okay, we'll see that. Now we will see the formula for sum of the terms, where R value is greater than 1. Okay, when R value is greater than 1, sum is equal to A into R power n minus 1 divided by R minus 1. This is how we can find out sum when R value is greater than 1. And also the number of terms should be finite number of terms. Finite means what? Countable number of terms. Okay, they should have given a value for this, for like 10 or 20 or something like that. There should be a value, countable value for this. When R value is greater than 0 but less than 1, in that case, sum is equal to A into 1 minus R power n divided by 1 minus R. Okay, 1 minus R power n divided by 1 minus R. This will be the case where R is greater than 0 but less than 1. Actually, to be frank, you can use the same formula for this also. What will happen if R value is less than 1? Okay, if I substitute in this A into R power n minus 1 divided by R minus 1, since R value is less than 1, R power n minus 1 will be a negative value. R minus 1 will also be a negative value, right? So this is negative something divided by negative something. Negative will get cancelled. So it doesn't matter that you have to differentiate like these two, but you can use any one. It doesn't matter, same thing. Only thing is, in this format you will get positive value in both numerator and denominator. That's all. Okay. The next type of series is infinite series. Okay, infinite series. What will happen if there are infinite number of terms? 2, 4, 6, 8, like this. Infinite number of terms are there. What will happen to sum? What will be the sum of all these numbers? Infinity, right? Yeah. So here R value is 2 greater than 1 and the number of terms is infinity. So here sum will be infinity. Okay. And here when 0 is less than R and R is less than 1. In this case, when there are infinite number of terms, sum is equal to A by 1 minus R. A by 1 minus R. This formula can be used. Many questions will be asked based on this formula, infinite series. Okay. For example, ball bouncing questions. A ball is thrown from ground level it reaches 60 meters. Okay. And when it bounces back, it goes half of the original distance. So next time it will cover 30 meters. Like this, infinite number of times it jumps and comes to rest. What is the total distance covered by the ball? Okay, in this case, in the first jump, okay, in first jump, total distance covered is 120. In second, up 30, down 30, so 60. 120, 60, then 30, then 15. It will go on like this. Common ratio is 1 by 2, right? So here, first term is 120. Common ratio is 1 by 2. 120 minus 1 by 2 is 1 minus 1 by 2 will give you 240 meters. So that will be the total distance covered by the ball until it goes to rest. It will not be exactly 240. It will be very close to 240. If it is jumping infinite number of times, right? It will be 239.9999. It will be infinite number of times. So which is very close to 240. All right. So these are some of the formulas. These are not the only formulas. There are some special cases which can give answer very easily, right? When it comes to geometric progression, we'll all see those questions in intense placement training. Yeah, Jyoti, we will see that in the intense placement training for negative value how to do. Okay, don't worry about it. What is sixth term of the series? 1 by 2, 3 by 2, 9 by 2, and so on. So what is the common ratio here? 3 by 2 divided by 1 by 2 is what? 3, right? 1 by 2 is multiplied with 3 to get 3 by 2. 3 by 2 is multiplied with 3 to get 9 by 2. So sixth term will be a into r power 6 minus 1, right? N minus 1. So 1 by 2 into 3 power 5. 3 power 5 is what? 243 divided by 2. Okay, that will be the sixth term of the series. Or we can do like this: 1, 3, 9, 27, 81, then 243. This is very simple, right? Sixth term is 243. Okay. Very good, guys. Monisha, Adias, Sukanya, very good. See this. What is the sum of first 8 terms of the series? Sum of first 8 terms of the series. Now, this is a finite series. Number of terms is given directly, right? So, this is a finite series. R value is greater than 1. What is R value here? 2. Right? R value is 2. So, what we will do? Sum is equal to A into R power n minus 1 divided by R minus 1. So, that is 6 into 2 power 8 minus 1 divided by 2 minus 1. 2 power 8 is 256. 256 minus 1 is 255. So 6 into 255. This will give us 1530. That will be the sum of these terms. 1530. Yes, very good, Bharati. Mangaldeep, Rupal, very good. Monisha, very good. Sambhavi, very good. Very good, yes. Kashish. Shubhangi, very good. Okay, let us see the next question. Now, this is the, like, read this question completely and tell me what case should be applied here. Read this question completely and tell me what case must be applied. Is it finite series or infinite series? Can you tell that? Is it finite or infinite series? Okay. In the question itself, you can see repeated infinite number of times, right? So this is the keyword. You can consider this as infinite series. Very good. Infinite series, right? Okay. What is R value here? Now, perimeter of first, the largest triangle is 6. That means side value is 2, right? Side value is 2. That means what will be the side value of, that is, whatever distance is from here to here, that length will be from here to here, right? That is the side of second triangle, right? So side of side of first triangle is 2, side of second triangle will be 1. Midpoint means this is exactly half of this side, right? So this value is 1, that means this value is also 1. That is, the second triangle side measure will be 1. So perimeter of first triangle is 6, perimeter of second triangle will be 3. Similarly, perimeter of, what happens here? 6 into 1 by 2 is 3. Perimeter of third triangle will be 3 into 1 by 2, that is 1.5. It will go on like this. So the set of values we have here are 6, 3, 1.5, 0.75 and so on. Infinite, until infinite number of terms. Okay. Now here, when you have to add all these values, A value is 6, R value is 1 by 2. So sum will be 6 divided by 1 minus 1 by 2, which is 12. So sum of these perimeters will be equal to 12 centimeter. Yes, guys, very good. Very good. Very good. Okay. Okay, guys. So if you have any doubts, please mention in the comment section or send it to me on WhatsApp. All right. And yeah. So regarding our training, so few more seats are available. If you want to join as soon as possible. Talk to your friends. If you join as a group, you'll get some discount, additional discount. All right. Okay. Okay, guys. Thank you. Good night. We will see you tomorrow. From tomorrow onwards, we'll start with the reasoning topic. All right. Kashish, you are asking for one more question. I will give you a question. Try to answer this. Consider this as an assignment for today's session. Okay. So consider this as assignment, guys. There is a building which is 80-meter tall. Okay. A basketball is dropped from top of this building. Okay. From the top of this building, a basketball is dropped. It hits the floor and bounces back to 2/3 of the height. Okay. Bounces back to 2/3 of the height. All right. So keep it as 90. It will be easy for calculation. 90-meter tall building. A basketball is dropped from that. It bounces back to 2/3 of the original height. And it bounces like that until it goes to rest. Infinite number of times. What is the total distance covered by the ball? Okay, total distance covered by the ball. Try to find this out and give the answer in the comment section. All right. Take a screenshot if you want. Okay. 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 Fine. Very good, Mangaldeep. All right, guys. We will see questions. Okay. Finding missing number, finding odd man out, right? Those kind of questions. Okay. Thank you. Good night.